Good afternoon, welcome back to the workbench. Today I'm having a look at this hairdryer here. This is my mum's hairdryer in fact, and it doesn't work. It's not really a hairdryer anymore, it's more of a hair blower, or maybe a hair chiller, or brain chiller possibly. If you've got wet hair and you use this, it's cold, well it'll just freeze your brain, which is not particularly useful, unless that's what you really want, but I'm guessing most people do not. Now, this is a Cascade. It's I don't know, sort of a basic generic brand from, I don't know, the Warehouse or Kmart or something. Can't remember. It's pretty old, probably like at least 10 years, maybe 15, maybe more. It's a model DS-925. It's had a pretty good run, I suppose, but even though it claims it's 1,600 watts, the amount of heat output of this is pretty much just from the motor, fan motor, and nothing else. So the heating elements are not running whatsoever. It's obviously not a professional grade thing or anything like that, but it does have a high and a low setting, and it's got a little button on the side, a sort of trigger thing marked cool, which when you press that, it makes you cool. Well, it cuts power to the heating elements and obviously blows cold air if that's what you want. However, that's a good point thinking about it. That could in fact be a potential source of a fault. If this button is not working properly, maybe the switch is broken, it may be running cool all the time, and there's no, it's as if you're pressing it the whole time, whether you're pressing it or not. It's also a possibility that one of the heating elements could have blown out, could have burnt up, broken or something, or if it was dropped, for example, it could have broken. Or it could just be a wire has fallen off. I don't know. There's not much thing go wrong with this though. I guess it's basically, yeah, it's a motor, it's a heating element, and it's a couple of switches. It's a pretty basic thing. There's not much to fail. There's probably also a thermal cutout or a fuse or something somewhere, which is also potentially a source of a problem. I notice it's the kind of thing that often fails. The thermal fuse cutouts can just fail over time, just stress from high voltage or just being in a hot environment, even if they don't reach their trip. Their tripping temperature, they can still just kind of degrade if they run close to that, I guess. And yeah, sometimes they just fail. So, or it's a possibility, of course, that you could block the output here and you get the thing to overheat, doesn't actually burn out, but the fuse goes. So yeah, I don't think that's what would have happened. But yeah, at least not covering it. I don't think that would have happened. But if there was a fuse there, it could have just failed from old age. Like I said, I think this is at least 15 years old. So yeah. Anyway, there we go. So let's have a look inside and see what's what with it. Yeah, hopefully we can get it fixed. Alright, let's have a closer look at this thing. So as I said before, it's meant to be 1,600 watts, but it's definitely not outputting that much power. It's a DS-925, if that means anything to anyone. Yeah, it's a hairdryer, as you can see, and there's the cool button, which I'd say is a potential suspect for a fault, like this, where everything else works, but it doesn't blow hot. But we shall find out. Anyway, I've got this screwdriver here, which I've, kind of a custom screwdriver I've made, because the screws, if you can see there, possibly, I'm not sure if that shows up, but you can see they're almost flathead, but not quite, because they've got a little chunk, well, not a chunk, but more of a raised thing in the middle. Basically they're like half a slotted flathead, but with a groove cut out in the middle. And I've got the screwdriver here. I do actually have a proper bit for these type of screws, but because this one is quite far down in the body there's no way to reach it. It's just one of those little hex bits. But I've got the screwdriver here, which I actually kind of made a long time ago as a kid, which is basically does the same thing. You can see I've cut a little notch out of the end with a hacksaw or a file or something, I can't remember. But basically this was a just standard flat blade screwdriver. And I filed the edges down to make it thinner, make it narrower. So that was filed these sides down, and then I cut a little notch in the end there. And this is a very cheap screwdriver. It was from a pretty cheap set from a $2 shop or something. it had like 2 Phillips screwdrivers and 2 flatheads, and one wasn't even a screwdriver, it was just like a pointy stick. It was like a Phillips without the slots cut. So I don't know if that was a manufacturing error or just some sort of weird joke. I don't know. Anyway, but yeah, the screwdrivers are basically pretty terrible. The Phillips ones just bent as soon as I tried to use them, and the flatheads pretty much did the same thing. And this one I just thought, well, it's I had to open something like, I think it was a toaster actually that I opened. At the time it had the same silly little tamper-proof screws, and I made this, well, modified the screwdriver to fit, so it should work pretty well on this as well. So we take this out. Actually, you know what? What I'll do first is give it a test. Let's just actually see. Let's verify what happens. I've got a thermometer here, just for a laugh. So let's plug it in. Let's turn this on. What do we get? 15 degrees Celsius. Yeah, that sounds about right. So if I turn this on to speed, well, this will probably be pretty loud, but turn this on here. You can hear it works. It's slightly warm. Like I said, there's obviously heat from the motor, that kind of thing, but it's not very hot. It's only, yeah, not much at all. Put it on to high speed. It's very slightly warm, very, very slightly warm, but not very warm at all. Yeah, not hot enough at all to be a hairdryer. It's just of interest. I wonder. I'm pressing the cool button here. Yeah. Pressing the cool button makes no difference. You're still getting warmth, barely warmth out of here, so I reckon that's just warmth from the motor, or something like that. Anyway, it's not very hot. I don't know what the temperature of this is supposed to be, but I'm sure it's got to be more than 30 degrees. Anyway, so let's see. So there's that. Yeah, it definitely doesn't work properly. It's lukewarm. It's barely warm. It's not hot. It's not anything like that. But you can see the motor works at both speeds. It's slow and low and high. So that's interesting. Anyway, we let's see. Let's take this out. So obviously, yeah, the low and high switch seems to be working, at least probably. I don't know if that's just for the motor control or if that switches the elements or something as well. I assume it would do both, unless the difference between high and low is literally just fan speed and not temperature. Don't know. Wouldn't have a clue. Anyway, that just comes off. It's a pretty simple thing, and we can see we've got a fan, as you'd expect. We've got the switch here, so that's just a standard switch there, with a little actuator plate thing on it. And yeah, we've got some stuff here. There's a diode, so that's possibly the fan is, well, possibly that's being used to cut the fan power in half, basically, by chopping off one side of the main sine wave. just sort of blocking it, so you get half as much power to the motor. That could be what that's for. I don't think you'd be able to use that to limit the power to the heating element, because its diode is pretty small, and right next to that plastic switch wouldn't really make sense because it would get pretty hot. So I'm guessing that is going to be for the fan. Notice this the switch assembly is melted in with some sort of melted plastic, so that's annoying. So I'm not going to pull that straight out. This we got here, this cool button thing is mounted separately, so I could take that out and have a look at it. Switch looks okay inside. It doesn't look burnt out or anything, but we know that already works anyway, so don't think that's a problem. Could be, of course, the element itself. So there we go, that just comes out there. So we have, what do we have? We have a bunch of elements. Nothing looks broken. Not that I can see anyway. Not obviously. We've got some wires, everything's crimped on. We got, it looks like a bridge rectifier made out of 4 separate diodes on the motor, so I guess that's a DC motor, and they're running the rectifier there, which makes sense, I think. Yeah, because an AC motor will not necessarily run in the same direction every time you start it up. Depends on what point of the sine wave it gets power. So yeah, you have to have extra circuitry and stuff or something to make that work, so it's a bit more complicated. So it's probably easier and cheaper to just get a bridge rectifier and use a DC motor. Anyway, I mean, there's a little bit of burnt hair and stuff lying around in here, but the actual heating elements seem to be fine. I can't see anything. There's looks like an overload thermal cutout switch. I can't see a thermal fuse. There's this diode here. Don't know what that's for. Unless that's possibly is that limiting power to the whole thing, or we do have what looks like 2 sets of elements, because we've got these thicker ones here and then these thinner ones there. So I'm guessing it has 2 elements. Probably that one will run on low, and then on high it'll either switch to this one or it'll switch both of them on. The diode does seem to be in series with this heater, and it looks like there's a wire, this grey wire can bypass it. So I'm guessing, well, I guess the thick heater can be driven either directly or through this diode, which would imply that yeah, that cuts the power of that heater. Now maybe, yeah, who knows, maybe they run this one all the time, either in high or low, and then this one is added. I don't know. I have to draw up a schematic and find out. But yeah, I mean, even if that diode went open circuit or something, or short circuit, then, you know, if it was short circuit, you'd get full power all the time, whether you were in low or high. And if it was open circuit, you'd only get power, I guess, in the high position, but you should still get power there. But in this case, we get barely any heat in any position, regardless of anything. So I'd be looking at something that's preventing power getting to the entire element assembly, which could be like this thermal switch here. It doesn't look like a fuse, and like I said, I can't see a fuse anywhere really. There's some coils, inside some tubing there. It looks like they're after the bridge rectifier, so I guess that's just suppression for the motor or something, or filtering. There's a tiny little capacitor there, 224. Don't know if you can see that, but there's a little ceramic cap in there. But again, I mean, if that failed, wouldn't really do it. So I'd say it's kind of strange. I wonder if it's just like a wire has come loose over time, because actually everything looks pretty good here, and the element doesn't look bad. The only thing I can think of is maybe this this overheat protection thing here could have gone open circuit, could have failed somehow, but everything is riveted on, and yeah, because I'll have to do some probing around. Let's check this diode here. That diode has a 0.5 voltage drop on it, so it's obviously fine. Let's check from one end. I don't know what resistance this heating element will be. Let's check from one end of this heating element to the other end. You get anything? Nothing there. So that's interesting. Maybe the heater does have a break in it. Maybe it's just not obvious. Where's the other end of this fine one? It goes from there all the way around to here. Let's measure that. That's a terrible way to do this, isn't it? Well, we get 136 ohms on this small wire, but doesn't seem to be anything to that end. Wait, hang on, there's like a center tap point here. Do have continuity to there, 25, 26 ohms. And what about from that point to this point? We get another 24. Okay, so oh, there is a break. Yeah, there is a break. I don't know if you can see, but this thick heating element here has got a tap point, or maybe it's just where they've connected. Yeah, it looks like it's just where they've connected these two together, so it's joined at this point here on this rivet. I'll take a photo and show a close-up, I guess. But yeah, this one side of this element has burnt off from this one, and the other side is connected. This lower side here is connected to one side of the rivet. You can see the wire going across there. Sorry, it's not really in focus, but yeah, it goes across to this side, but this one, the continuation at this side, goes underneath and connects to this side of the rivet, and that's actually burnt out. That's burnt off. You can see possibly in the gap there, well, you can see there's nothing there. There should be another little wire going across. So that's obviously the explanation. So maybe the heat that I am getting is coming from this smaller element, possibly. And then this larger one is just doing nothing. So yeah. I wonder if it would be possible to get some kind of crimp thing and crimp this wire here onto this other one, because that's all it would really need. I don't think, I mean, obviously you can't solder that, because when it heats up it's just going to melt. So yeah, I guess if I can reconnect those two segments of the heating element back together, it should work though. I know exactly the kind of little crimping thing that I would need. I've seen it before, like in illuminated switches, where they will crimp like a neon globe lead to the end of a resistor. I've seen that before, but I don't know what the thing is called. But there we go. Yeah, well, that's that. That's an explanation. The element is burnt out right on a point where it's crimped on to this rivet thing. So it's probably was a point of physical stress there, and just over time, heating and cooling up and down, it's just eventually snapped. Probably due to just physical fatigue of expanding and contracting so many times. It was probably under too much tension or something when it was made in the factory. Whether that's deliberately done or just the way these things go. I've seen that in toasters as well. The heating element usually fails next to one of the rivets, because that's going to be a source of greater physical stress. Where the element is trying to expand, and of course it is being held tightly by a rivet somewhere. So yeah, not surprising really. That's the kind of thing that happens. They don't typically tend to break, somewhere in the middle, unless you drop them or they get hit or something. It's usually always near the termination points where I've always seen these things usually break. But anyway, yeah, if I can figure out a way to fix that, I'll come back and do that. Otherwise, it may unfortunately be a case of get another one. So either we'll see you in the next segment, or we'll see you in the next video, depending on whether or not I actually fix this thing. Right, so I just had a look online, and it seems like the idea of crimping the two broken pieces back together is probably not a bad idea. It looks like other people have done that with things like dryer elements, and I'm sure you can do it with pretty much anything really, as long as you got the wire to work with and something to crimp them together. And I looked around in my parts and that, and I found this little crimp terminal thing, this ring terminal here. It's got this little crimpy bit on the end there. It's a non-insulated one. And yeah, it's just got the two split things, and they just bend over on the wire. And I figure if I cut this off, I can cut the terminal end off, and I can just use this metal end part of the crimp. Sorry, there's not in focus with all the stuff in the background. It doesn't really work, but I mean, you get the idea. It's a crimp terminal. You put the wire into that cylindrical part and squash it down on the wire, and then you can got this terminal you can screw down to whatever you're doing. So yeah, if I just use that part, I should be able to do it. The only trick will be actually getting it in there, because there's not a lot of room to work with. I'm hoping the breaker's here at this point, so hopefully I can bend the element out and get it next to the other one, and then somehow get this in there. I mean, obviously I'm not going to use the whole thing. I'll cut the ring part off, but yeah, hopefully get this, probably if I can put it like in here, get the two wires passing through it, and I can use the cutout in this mica sheet to sort of fit that in, sit that in there, and then I can crimp everything around that. Now we got this this kind of You can see that white wire, sort of cord or something, it also is holding the element in place to stop it sort of moving around too much, it looks like. So yeah, I have to try and get that out of the way and crimp next to it. Obviously I want to crimp that in there as well. But yeah, it's a bit tricky and tight, but hopefully, I mean, if I can get this in here and get some pliers in there and everything and actually manage to get everything together, I guess that should fix the problem. So I don't think I'll be able to film that because it's going to be really tricky and really annoying. It'll probably take half an hour, so I won't show it, but if it does work I will show that in the next part, and we'll see. Hopefully that should get it working. Hopefully. We'll find out. We'll find out indeed. Alright, well, yeah, that took a while. About half an hour, as I suspected. I've cut the end off there, as you can see. Got the rest of it in here. I don't know if you can see that there, but you can see where I've crimped that on, hopefully. Got some close-ups if you can't see here, but there you go. It's reconnected together with this little piece of metal. I did manage to break the sort of white string that was holding this up. I don't know if that's necessary or not. Hopefully it's just some kind of manufacturing aid and not required for use. I mean, this element is pretty sturdy anyway, so it may be fine. Hopefully. But yeah, there we go. That all seems to be reconnected, and if I check the resistance all the way from one end to the other, we get 46 ohms. So that is about well, it should be 50, I guess, but there we go. It is twice what it was before of the two sections, so it seems like it's got a connection there. I guess now we have to power it up and see if that connection is actually good to support the full power. I don't know, but there we go. Let's see. I think that goes around that way, so that should just go back in there. It just slots down there. These wires, I think, routed this way on either side of this sort of slider thing, something like that, because that's where the this main switch slides up and down. That seems to clear that just fine. Alright, so that seems to be in there. Let's get the let's get this here. Let's put the back on. Seems to... wait, am I supposed to do this top bit first, I think? Yeah, there we go. Alright, that goes back on. I'm going to put the screws back in. There's only two of them, and I don't really want the thing falling apart if I'm trying to test it. And in any case, I kind of have to have the thing together to test it anyway, otherwise the airflow wouldn't work and the thing would overheat, I suppose. So there we go. Let's see. Let's back together. Let's get this down here. Get this back again. Get that out of the way, I suppose. Yeah, got our temperature probe there. So that's turned off. And hopefully it doesn't explode when I turn it on. Let's try low. Is that hot? I can smell hotness. Yep, look at that. It's going up a lot more than it was before. 50 degrees. 50, 60. So that seems to be about, I don't know, 60 something. That's definitely more than it was before, and it definitely feels warm. So that's good. And if we let's try it on high. $67, $70, $75, yeah. Seems like it's working. 80. Haha. Nice. Does the cool button work? Yep. Now it's going down. So that's with the cool button held in, and it feels cold coming out. I'll let go of that. Immediately it starts heating up again. You can see the temperature rising again, going back up. Yep, nice and warm on the end there. Excellent. Seems to be working. So that was definitely it. The heating element had broken. And with the new reconnected, it seems to be fine. No idea how long it'll last, considering the, like I said, I don't know if that, who knows? But it's working now. And that's pretty much all you can hope for, I suppose. I think I did a pretty good connection on that, so as long as that that sort of suspension thread that ran through the middle of the heating element is not highly critical for the longevity of the element or anything like that, it should be okay, I suppose. Yeah, there we go. That's useful. Well, there we go. There we have it. That's the hairdryer seems to be fixed. Definitely heats up a lot more than it did before, and it feels normal. Feels like the right temperature you'd expect for this sort of thing. And yeah, seems to be working again. Like I said, I don't know how long it'll last necessarily. But I mean, at this point, it's like I said, it's over 10 years old, probably more. For something that was probably less than $50, I would say if this repair keeps it going for even another year, I mean, yeah, it's pretty much, you know, it's the lifetime it's had already is probably far exceeding that of what you'd expect anyway, most likely. At this point, it's pretty much any extra time is a bonus. Hopefully it'll stay working for longer than that, though. Hopefully it'll stay working for a long time. We'll see. If it stops working, I may update this, but I suspect it should hopefully keep going for quite a while. So that's good. So there we go. Just goes to show. So that heating element was quite thick, and I had to bend it around a bit with my pliers and stuff. Seems to be a bit tougher than I expected. It's not doesn't break very easily, I suppose, at least not physically. So unlike, say, a toaster element, which seems to be pretty easy to break, or looks like it would be anyway, this seems to be quite thick and tough. So you can sort of bend it around a bit. Don't have to worry too much. I've never done this kind of thing before, so that's an interesting thing. But yeah, just get like a little crimp terminal and cut the terminal off. and then use the end bit to clamp it round whatever's left. Only tricky because of the shape. I sort of had to uncoil a little bit of the wire and straighten it out and get it the right angle through the crimp thing and crimp it on. I had to sort of use my side cutters to start the crimp off because they've got the narrow point, the narrow edge here to sort of crimp down one side of the connector, because you've got the sort of the circular thing, and you've got two bits coming up like that. So to crimp like one down first, I had to crimp one down first and then sort of squeeze the other one over the top, because it was bigger than the wire you'd expect for that size terminal. But I didn't have anything smaller really. But yeah, that seems to work pretty well. So that's that. So it can be done. You can repair the element. Obviously not by soldering it. That would be pointless. Maybe you could spot weld it or something. I don't know. But that would probably be even trickier to try and get some kind of a spot welding thing in there. So I think crimping it together is probably the best option, actually, as long as you got the space for it. So yeah, and hopefully this will work a wing. I mean, this thing is designed so that the air blowing over the elements, they don't even light up. They stay black. They don't even glow. So I think the actual amount of sort of thermal expansion and contraction and all that kind of thing is probably, hopefully, fairly low compared to something that would actually light up and glow. So yeah, I guess it's maybe I'll be lucky and it'll work for another 15 years. Who knows? We'll find out. Yeah. Anyway, so that's that. How to repair a hairdryer, I suppose. Burnt out heating element. Not surprising. It's a kind of common thing, I think, with these kind of thing. The only other thing I'd think would be the motor, but that seems to be working pretty well in this one. That would probably be difficult to fix if you need to get a new motor for it, but the element, not too hard to put back together, it would seem. So that's cool. Anyway, if anything changes, I'll probably make another video. But for now, that's that. So see you next time.